Here's your review for the third and final exam. First of all, I emailed you the questions earlier, and I guarantee you those questions I sent directly relate to questions that you will be asked on the exam. These will be more of fill in the blank. I'm sorry, not fill in the blank, but short answer type of questions as opposed to multiple choice questions. There'll also be some definitions. So the vocabulary list 3 is in play for the exam. I haven't decided how many words from that list I'll have on there, but there will certainly be words from the vocabulary list. Okay, let's cover the review for the multiple choice. Let's start with the midstream industry. I want you to remember, proportionally speaking, what products get moved more by pipeline than others. And then I also want you to remember our class discussion why rail shipments took off, and remembering the discussion about the economics of rail versus pipelines, and also the safety records will help you answer those questions. So the slides I'm flipping through obviously mean they're not the source of a question. There might be a question about batching on the exam. I don't know why that one's being so frustrating. Okay, this is another source of a question. What has greater variance in demand on a daily basis, oil or natural gas? Obviously, you can see it's natural gas. And so then think about ways that the industry handles that daily variation. As I make this video, it's snowing outside, so it's a cold day. Good, all of us are using a lot of natural gas today, probably. At least my house is heated by natural gas. And so we see that practically put into place. Not going to ask you to list off the major midstream companies, but I do want you to be familiar with master limited partnerships. So you're going to want to know and understand this slide. Again, no questions on anything like this. As far as the LNG market, there is a question on the LNG market, and you're going to want to understand when is it good for or logical for a country to export LNG, and when is it logical for a country to import LNG? And some of the major players in both of those markets would be good to know. And one other thing that would be good to know about LNG is that the most expensive part of the process is the liquefaction of it. This is the liquefaction plant in Sabine Pass down on the Gulf Coast. And this is where all the bucks are in the LNG process. It's relatively easy to regasify it once it gets to its destination. Now we turn our attention to the downstream industry. I do want you to know some of the physics and the business of the refining process. I'd like you to make sure you know where the refineries are clustered, and especially that the majority of them are on the Gulf Coast of the United States. Don't need to know this sort of stuff. Don't need to know this sort of stuff. I do want you to be familiar with the product slates and the basic functions in the distilling industry. Just keep in mind, too, the value. These are the high value products. Sometimes they'll be called light distillates, not very often. Gasoline obviously is by far the one that's produced in the most quantity and is the most value. Then you have jet fuel, diesel fuel. These are called the middle distillates, and I'll show you that on a chart. And this is the real heavy stuff, and this is the stuff that is less valuable. Okay, this chart shows you that refineries vary in their output, and this has to do with the equipment they have on board. You can see the different percentages of gasoline that come out of the various refineries, and also the various percentages of middle distillates that come out of the various refineries. And it just has a function to do with what sort of equipment they put into the refinery. Also, notice that the different types of crude produce different amounts of the various products. So if you have condensate, that's a very high cut of gasoline. Then as you go to low light sulfur, which is light sweet crude, which would be like WTI, you can see compared to condensate, the percentage of gasoline is lower. And then you see the middle distillates and the even worse stuff come up more. Then as you go, for example, go to heavier or more sour crude, you see that the percentage of gasoline goes down, and typically middle distillates go up, although here, this is such very heavy crude, produces a lot of the very heavy byproducts, the asphalt and things like that. Now for processes, you need to remember that the first stop is the distillation towers, and have a basic understanding of what distillation is so you can rewatch this video if you would like to. Then keep in mind on the next slide of cracking. This is where you put a lot of energy into it, but I want you to understand that the basic product of cracking, the reason you crack, is to produce more high value products from a barrel of oil. So this is where you produce particularly more gasoline. You're trying to get more gasoline out of a barrel of oil by taking some of the stuff that might not be as valuable, a middle distillate, or even worse than a middle distillate, some of the very heavy products, and you put it through the cracking process to make more gasoline. Okay, moving on, don't need to worry about that. I do expect you to remember that refineries are very busy places, on the order of 90% utilization for a year, simply because it's a very expensive capital asset, so you want to use it. Nothing to be seen in any of this. Okay, that's it for the downstream industry. Shifting to the regulatory environment, I actually decided to start at the summary slide. So this is one of the key takeaways, is that state law, for the most part, guides oil and gas E&P operations. They set the rules for leasing. They set the rules for well spacing, for pro-rationing, those sorts of issues. Federal law, there's a lot of federal law relating to environmental and safety issues. Even though states can have guidance on those issues, these are the issues where federal law tends to be the most dominant. And the other thing I want you to remember is that we talked about the various issues, but I want you to particularly remember, go back and rewatch the video if need be, what was found from the 2017 EPA study on fracking. I want you to be aware of that. And those are the two issues from the regulatory slides. On to renewables. We talked about the idea of power density. And power density is per pound how much energy can something have. And this is the real issue with long-range transportation vehicles, is the power density of renewables, the batteries in electric cars, and for that matter, believe it or not, they're starting to have some electric airplanes. They're just not enough for long-range transportation currently under the current formulation. So this idea of power density is one that's important to keep in mind. Also, we talked about electricity usage and this concept of power varies throughout the day. So base load are the type of sources that basically are always on. Intermediate, these come on to take care of that normal daily bump, and then peaking takes care of hot days when power requirements is absolutely at their peak. So these run all the time. These run not all the time, but on very predictable bases. And these run only when you really need the power to keep up with a spike. And moving on, a familiarity with this might be a little bit helpful, but there's not a direct question from that. I contrasted for you concentrated solar power versus photovoltaic. And the real takeaway I wanted you to think of here is that this has the disadvantage of being more expensive than does the photovoltaic, but it has the ability to store energy after sunset, because once the material is warm, it can generate power for a while. This has the benefit of being less expensive and more flexible. I told you in the notes that you're really going to need to be up on net metering, so you may want to rewatch the part of the video where I talk about that, and you're going to definitely watch these two YouTube videos if you're not very familiar with it. For wind, know that the current production tax credit is 2.3 cents per kilowatt hour. That will be important to help you think through some of the questions. And I'm skipping over slides that you should already be looking at because they will help you with the longer answer questions I've already talked about. Make sure you know this rule of thumb that it costs between 1.2 and 2.2 million dollars per megawatt to construct. So in other words, if I were to build a 5 megawatt generator, and I'm not sure that they're even possible to build them that big, I would multiply 5 megawatts times 1.2 to 2.2, and that would suggest how much that turbine would cost me. In other words, between 6 and 11 million dollars. Also know that the turbines, simply because the wind doesn't blow continuously throughout the year, tend to generate, as a rule of thumb, about 33% of their rated capacity. So if it's a 2 megawatt generator and you multiply it times 24 hours a day times 365 days a year times 2 megawatts, you really get about 33% of that energy. Levelized cost of energy, good thing to understand. Go through well, actually, I'm going to do the math for you. I want you to remember that if we add up all the fossil fuel subsidies, they add to like $3.5 to $3.7 billion a year, depending on how you do the math. And if you add up all the renewable subsidies, that adds to about $9 billion a year. I'm not making a political statement there. I'm just saying when people talk about subsidy this or subsidy that, you understand that you know the figures and you know the categories under which they're being subsidized. And I think that's got it covered, but let me double check. Hang on. Okay, that should cover it. You'll be in good shape for the exam. I will see you in the computer lab at 8 p.m. on Tuesday night, ready to really knock this exam out of the park.